you for joining us for the IEEE Computer Society Standards webinar series, brought to you by the Standards Activities Board. With over 225 standards that transform the way we live, work, and communicate, the IEEE Computer Society sets the standard for design automation, simulation, testing technologies, Ethernet and Wi-Fi, quality assurance processes, systems architecture, DevOps, and more. Standards deliver best practice processes for developing market-ready interoperating systems, products, and services. You can have an impact by joining one of the over 200 IEEE Computer Society Standards working groups. Participating in one of the working groups grants you access to information that reduces risks, increases proficiency, and shapes the future of the industry. Help determine what's next in computing technology. Learn more about our standard working groups at computer.org/standards.
Okay, so hello everyone. Thank you for joining us today, and welcome to today's webinar from our Standard Activities Board series, and today's presentation from the Computer Society Cloud Computing Standard Committee. My name is Edward Au, and I am the Vice President for Standard Activities of the IEEE Computer Society. Before we get started, I would like to adjust some housekeeping items. This webinar is being recorded. You can ask any questions in the Q&A box you see on your screen. The speakers will answer as many questions as possible after their presentation. When submitting a question, please reference the slide. A copy of the slides and the recorded webinar will be emailed to you tentatively tomorrow. Now, circling back to today's presentation, the IEEE Cloud Computing Standard Committee, which is chaired by Steve Diamond, is chartered to promote the development of standards in all aspects of the cloud computing ecosystem. It facilitates the development and use of standard-based choice by cloud computing ecosystem participants, including but not limited to cloud vendors, service providers, and users in areas like the cloud application interface, the cloud management interface, the cloud interoperability interface, the cloud file formats, and the others. Today, I am very happy to introduce two of the senior leaders of the Standard Committee with all of you for this presentation. The first one is Dr. Joe Flagg, President of the Flagg Associates. He is an acknowledged expert in the area of software architecture and international standards, with focus on distributed computing, distributed management, cloud computing, policy-based management, business modeling-based design, and telecommunications operations and business system support. Among many important senior leadership roles he holds in different standard bodies, for here, Joe currently serves on the IEEE Cloud Computing Standard Committees and as the chair of the IEEE Adaptive Management for Cloud Computing Work Group, which is also the focus of this webinar. And then another speaker is Dr. Bob Bond, who is currently a senior group member for the Transformational Networks and Service Group and NIST Cloud Computing Program Manager. Bob is vice chair of the STEAM Working Group that is chaired by Joe. That is, the working group is responsible for developing a PAR, or you can consider as a project P2303, the standard for adaptive management of cloud computing environments, which seeks to define foundational material for the adaptive management of cloud computing ecosystems. So once again, welcome Joe and Bob. Thank you very much for accepting our invitation to deliver this informative webinar. Now I will give the floor to both of you to start the presentation. Joe, please go ahead.
Thank you, Edward, and welcome everybody. First things first, I want everybody to understand that these views are personal views of Bob and myself, and have been are developed by ourselves and by the team that we're leading in P2303. So it's not certainly a formal position of the IEEE. So as a quick outline of what we're going to do, I'll do a brief introduction on why we decided to proceed with this work. And then to help the audience understand and how we're driving this work, one of the things that we did was we developed a number of use cases. Bob is going to present one of the use cases that has been instrumental in driving it and the work forward and directing the work. And then finally, I'll wrap up with a few slides on the work as it currently exists. Now, we're as you'll see later, this is a work in progress, certainly not a complete work, but we will give you an update on where we stand now. Just as Edward mentioned, the P2303 working group is sponsored by the Cloud Computing Standards Committee. We've been active since 2023, and we're aiming for an initial standard in 2025. Now, what I should mention here is that this is certainly not the last of the standards that we foresee for management in cloud computing. In fact, this is more a foundational standard for management in cloud computing. I think the best way to phrase this would be is we tried not to boil the ocean with the initial, but rather to lay the groundwork for future work. So this, we anticipate that there'll be significant amount of future work after this standard is released. Just as a quick acknowledgement, the officers of P2303, myself as chair, Bob as vice chair, actually he's vice chair twice. See, Bob, I got you there. And Ricardo Alfaro is our secretary. So why do we really need a new approach to management for cloud computing? Well, if you're familiar with management in the past, management, almost all management has a tendency to be very reflexive. That is, act after something has happened. In the case of most management today, it's after something bad has happened. And it's to, if you will, correct what bad has happened. And the other thing that another interesting characteristic of most management systems is, although they may have been developed with the original environment in mind, most management systems are very much out of date with the current version of the system being managed. That is because they're usually independent, and they don't change. They may change the environment being managed, but they don't change so fast themselves. They don't change themselves. The last thing that really is a problem in a cloud computing environment is most management systems are relatively slow, and they're really not designed to support a rapid response to potential problems that characterized a cloud computing environment. So that if something happens, usually you're talking about not being able to respond and not giving the customer users satisfaction that they want in the time frame that they want. So what we look at in cloud computing is we're looking at both rather than just a reflexive style of management, we're looking a way that says not only do we react to things that are happening, but we also want to anticipate things that could happen. For example, we might know that we're bringing in new resources, or we're changing software, or we're adding capabilities, we're adding additional users, whatever. We want to be able to manage based on those things rather than just reacting and being reflexive to things that have happened in the past. We also want to be able to not just be remedial, that is, fix things. We also want to encourage things, encourage positive behaviors. So if we can detect a stimuli that is positive in nature to the ecosystem being managed, we want to be able to encourage that and also look ahead, knowing when things are going to happen, or even predicting statistically that things might happen. We want to be able to be visionary. Put it in a different way, if you think about it, we want to not just be the person that puts out the fire after the fire is started. We want to be there so that we not only can detect smoke before the real fire starts, but we want to be able to create an environment where we prevent fires from happening. The other thing that we want to do is we want to be able to certainly keep the management environment in sync with the environment, the ecosystem being managed. In this case, what we do is we're saying not only do we change, react, or encourage behaviors in the ecosystem that's being managed, we want to be able to change both the monitoring capabilities of the management components and the analytic components and the decision components of the management environment, so they are consistent with the environment being managed. And finally, obviously, we want all of this to be much more rapid and in reacting to and encouraging behavior in the system under environment. So that's basically the reasons why we started this work. What I'm going to do now is to turn it over to Bob, and he can run us through the use case, one of the use cases that we have been using to guide this work and to drive it. Bob?
Thanks, Joel, and welcome everyone. So as Joel mentioned, I'd like to describe an adaptive management use case for cloud computing. The use case is about environmental monitoring and of your house, right? So for example, our goal is simple here. We want to set a comfortable temperature for your house that can be maintained year round. So like Joel says, it's simple enough, but we want to develop some of the approaches and the vision that Joel had just described into this simple use case. So on the left, you see our basic house. Our basic house consists of a couple of simple components: a smart thermostat, a boiler, and a water source. In addition, it could have auxiliary components such as solar panels, an auxiliary generator, and a fuel source. Again, our goal is to keep the basic house at a constant temperature. Now, the basic house is not a closed system. It has to interact with the rest of the world where it's going to get its power and fuel. So overall, we're going to have information flows come from the house to the rest of the world, as well as power and fuel, as I mentioned. So now in the next slide, I'm going to try to break down these individual systems. So for a single house, here is the power transfer, flow. So we have our power provider on the right-hand side, power grid in the center that delivers electricity to the house, and the house is then the boiler and the water source are powered up, and the solar panel is able to transfer some power back to the power grid, as well as the auxiliary generator when that's in use. So that's not the normal case. The normal case is where we have our power grid, our power supply from our power grid. When the auxiliary generator kicks on, that means that there's something wrong or there's been a disruption in the power grid, so we have to work off of that. The next part is, what about the fuel for the auxiliary generator? Well, that's going to be needed when the power grid goes down. So you always have a fuel source in the backyard and a fuel provider that has to do the fuel delivery. And then the fuel source can power up the auxiliary generator and provide power to the boiler. And the entire process gets started by a simple information transfer at the smart thermostat, where somebody sets their, quote, comfortable living temperature. So now I'd like to go on and, like I said, develop some of those approaches and visions that Joel was talking about and describing. So we have, just let's look at the basic information flow that we've broken down in the group. So we have, in this image, what we've added are 3 cloud providers in the middle. And then over on the top right-hand side, we have information from the National Weather Service and the home monitoring system, right? That's monitoring what's going on in the house. And I'd like to point out the central cloud, the cloud in the middle. So this cloud is actually connected to the home monitoring system. And for example, the boiler could be connected to that, and who's monitoring the boiler or the services for the boiler might also monitor the auxiliary generator and the solar panels. So then they can take that information and then consolidate it and do data analytics on that. Finally, we have our fuel provider at the bottom, and he also has his own cloud and services that he maintains by monitoring levels in the fuel source, and which is also connected to the home monitoring system and gets live data from the National Weather Service, so they can do further predictions on what they might need going forward in the future, if a bad storm is approaching or if it's becoming too hot. So a complete image of the simple architecture is this. So I tried to lay it out in layers and build that up so you could follow it. The next image is, what if we took this out a few steps further, right? A larger domain, and we're going to look at a neighborhood, which consists of several of these houses in a community. We still have to maintain a certain level of fuel that goes into the community, but this time the fuel provider has data from each of the houses on how much fuel is in each tank and can decide when it's the right time to make an optimum delivery. Or like I said, he might want to change this based on if he expects very bad, cold, snowy weather. So you might want to get out there sooner because the overall power grid might go down, and then people will really depend on his services. So if I take this out into an even larger domain, a complete region of multiple communities, I give you several red lines of information flow, but these are basically the individual individual components that we saw on the previous slide, just taken out to a much larger extreme, so you could see how many more things have to actually be managed in this environment. Again, anything that can work to help optimize fuel to each customer, and the temperature that is set in the house. For example, you might not want to necessarily say, well, I have to keep it at 72 degrees when it's 0 degrees outside. You might be willing to go down to 65 or 68. So that's good. You'll be using less power, and you'll be able to adaptively manage this, or the people in the home management services will. Lastly, I'd like you to consider what happens to the data at the end. So there's also management of downstream direct and derived data. There could be several data aggregators, derivers, and resellers in the chain, and then they will sell that data or provide that data to a litany of data consumers. Who are those data consumers? Well, that's yet to be determined, but there are probably going to be some people out there if there's a market for providing this data. So I'd also like to point out there were several questions brought out by this simple use case, which are service provider related. So how would I register and identify a new cloud service provider? What about a cloud provider? How would I select cloud providers? Or even if I were the individual customer, I don't like the service from that cloud provider, how can I change over? How does my data get handled there in that example? The consumer related, how does a community region membership affect services? Again, not everyone might want to be in that same cloud. And then finally, there's data related and interoperability and portability related questions. Among some of them is, how do you handle multiple regulatory and administrative domains? And that seems to be a large question that permeates through this system. So with that, I'd like to stop and pass it on back to Joel. So thank you.
Thanks, Bob. As you can see from the use case, management of an environment, and that's not a particularly complex environment. And in case you're curious, that environment was, although somewhat fictionalized, is actually not really. It's actually an environment of one of our group members' cabin up in Vermont, and it's exactly basically the environment that they're dealing with. So it's not something, even the simple case is not something that's too far in the future. So as I mentioned in the introduction, what we're looking for is two different styles of management here. Traditionally, everything has been reflexive. That is, the management reacts to detected events that pretty typically negatively impact the system being managed. I come from a long time ago from a telco environment where basically you monitored things, and when things got out of whack, you had alarms and you had trouble tickets and all sorts of good little things like that. And the idea was that you were effectively rated on how your trouble ticket was handled. And the goal in those environments was to minimize the, quote, damage, unquote, caused by detected events. Now, I say that, except that there were some exceptions. And in the Bell system, for example, one of the things that we did was we actually managed to the worst case scenario, otherwise known as what we used to jokingly call the Mother's Day scenario. We built the network to handle a load that was anticipated on Mother's Day, because that was traditionally the highest day of volume in the network. So in that case, we were slightly falling into the second category here, that is anticipatory management, but generally it was reflexive. What we want to do in a modern environment is much more manage not only to a reflexive style, but also anticipate, detect, and encourage actions that positively affect the system being managed. So what we've done is, in the early part of this work, we sat down and we identified 4 different styles of management that mat along this management continuum cube. We have on this 3 scales: a cognitive scale, that is activities that are known all the way up to a fully predictive, probably a probabilistic predictive, a time scale ranging from things that have happened in the past to things that will happen in the future, and an operations scale that ranges from very tactical things that are focused on individual items to strategic that are there to implement goals. And what we've done is we've identified 4 styles of management. Reactive management, that is what we traditionally see in the world. That is, fix something that has happened and make sure that its impact on the ecosystem being managed is as small as possible. Periactive management, that is to fix something that is happening, detect something and try to fix it before, try to either encourage it or fix it before it has a larger impact or it has little impact at all. Those are pretty much what management does today, that is reflexive management. But then when we get to the anticipatory management, we start talking about preactive management, that is, act for a predicted or known future that's going to happen. We know that, for example, we're adding new equipment, or we're adding, perhaps we're buying another company, and we're incorporating the two together so we can start adapting the management systems so that they can manage both companies. And finally, at the most predictive, strategic, and far out looking is proactive, and that is trying to predict the future and shape the future so that we encourage things that will stay keep the ecosystem being managed within conformance and within the goals of the system. Traditionally, when we look at management, we talk about a management cycle, kind of like a similar to a policy cycle. And what we generally have is a stimulus that then feeds to an evaluation or analytic component, which then feeds to an action or accomplishment component. If you were talking about a policy-based management, ideally that would feed back to the stimulus. Unfortunately, in most legacy management systems, feedback and changes to the or feed forward and changes to the stimulus environment don't happen very often. And what we find is that the management system itself is very much usually out of sync with the system being managed. And in fact, changes to the management systems themselves are pretty much an afterthought. And in fact, so what's happening frequently in management domains is the management system is unaware and usually unchanged. So it's actually trying to manage something that has been changed many times over the era of management that it's been managing. And so it's effectively managing, making observations in the stimulus on stimulus, making decisions and evaluations, doing analytics that are frequently have nothing to do with the system, the state of the system being managed, and even worse, may have nothing to do with the goals, the revised goals and ecosystem of the system being managed. So one of our early goals was, let's see if we can figure out a way to change this. And so what we've done is we've introduced a modified management loop, very much policy-based, that not only has a feed forward cycle, but is feeding back. So now when we, for example, detect a stimulus, we feed that back into a local domain knowledge base so that we keep track of the stimulus. When we do the analytics and evaluate what potential impact of the stimulus, again, we feed and come up with some, in the evaluation, come up with some suggestions that might change alter the system being managed. We feed those back into the stimulus and monitoring capabilities so that the stimulus capabilities are changed to reflect the suggestions that we have for modifying the system. So in this way, what we're doing is at all times, we're making sure that we understand not only what is being, that the system is being changed to positively impact the system, but the management system also is being modified and changed to reflect the policies, goals, and context of the system being managed. Now, by the way, in a minute I will talk a bit about this local domain knowledge, because we'll acknowledge that it's a lot more than just policies, goals, and context. I'll also point out that if you're familiar with John Boyd's work on the OODA loop, this is very much driven from the work on the OODA loop, which is, and John Boyd very much was of the style that management has to be. You want to manage as fast as possible, make decisions, and make smart decisions and informed decisions as quickly as possible, so that you can react and minimize damage or maximize positive impacts to the system as quickly as possible. So as I said, the local domain knowledge is actually has a lot more in it than we had originally put in there. We're including, for example, the goals of the ecosystem being managed. And by the way, goals are not a static thing. Goals can change. Also, we talk about the strategy, the ontology of the system, all of the policies of the system. And policies are not just policies that are of the governing body of the system being managed, or the owning body. It also can include such things as governance rules for governments, for regulatory bodies. It can be, and even include policies could include natural rules, things that natural laws and things like that. Also, what we will include is certainly models of the resources being managed, and models of information, the data being managed, and the staffing models. Now, one of the things that we recognized fairly quickly is that, for example, another thing at the knowledge base is, as we perform our analytics and pass suggestions for improvement or changes to a decision system, one of the things that we'll do is that we will log those suggestions, not only with the suggestions themselves, but also with the stimuli and why we made those decisions, or why we provided those suggestions. Again, those will be logged into the local domain knowledge base, so that if we encounter similar occurrences in the future, we can make a decision, an informed decision, on whether we want to do the same thing or change our behavior. Obviously, this goes with the old adage is that the definition of insanity is doing the same thing over and over again and expecting different results. Well, what we want to be able to do is to log them so we don't do the same thing over and over again and see the same stimuli occurring. If you look at adapting the loop that we talked about earlier, this is a high-level view of the system that we're working on in the standard. We have an adaptive stimuli and monitoring system that that handles the stimuli that are coming that are detected by the management system, and it also is handling those things, looking at those things with the contextual information, i.e., the context in which the stimuli was detected. So it's not just saying, "Hey, wait a minute, I've detected a fault on component X," but it's also saying, "I'm detecting a fault on component X with the following context, the following usage, the network capabilities, and the goals that were in effect at the time that stimuli was detected." Handing those off to a set of adaptive analytic engines that are customized for the local domain. Those could be anything from what I will refer to as static analytics. Those are analytics based on existing configurations, known models, things like that. Could also be probabilistic or stochastic analytics that are looking at things and saying, "Hey, wait a minute, given those stimuli, these are the things that could have caused them. These are things that could be caused by those stimuli occurring in the future," and that type of thing. So there's a fairly complex set of engines. As I said in the introduction, this work is foundational work. This time, we're not getting into the business of trying to specify what analytics should be developed or things like that. We're looking at that very much as future work down the road. The adaptive analytics engines then provide a set of suggestions. It could be one or more, but there's an interesting difference here with how management has been traditionally done. We look at the suggestions here, also including metrics for the suggestions. And the metrics can be such things as a cost, that can be cost in a financial sense, can be cost in the sense of performance. It can be cost in the sense of added resources, or cost in sense of added staffing. So it can be a combination of all of those. So when we're providing the suggestions to the adaptive decision management system, what we're saying is, "Hey, here's a set of suggestions based on the costs and based upon your current knowledge of the local domain. You can now choose one of the suggestions if there is a choice to be made, and you will know effectively, or you will have some idea of the cost associated and the benefits or actually penalties associated with making that decision." Again, all of those are logged in the local domain knowledge base, so that when we make that decision, we know why we know the decision, why it was made, and the costs associated with the decision. Also, obviously, we're feeding that back to the adaptive analytic engine, so the analytics now know, "Oh, wait a minute, they chose decision A over decision B, C, and D," and analytics in the future may say, "Hey, wait a minute, if we get a similar stimuli with similar contextual information and goals, we may or may not want to make the same set of suggestions. We may want to change the suggestions." And again, as you can see, all of this is fed back into changing the monitoring and stimuli generation loops, so that each component of the adaptive management system changes and reflects the current system under being managed. But an interesting question here is, what happens when we get to the point where we're not just in a local domain. As you saw from our use case, and a fairly simple one, we could argue that a local domain is a house. Well, it's not very often that you're in an isolated environment, and you most often are going to be federated with many different domains. You may be crossing many different clouds. So we're also looking at how do we modify this and adapt it to handle many different environments. So the first thing we have to understand is that there will be stimuli monitoring. Well, the first thing I should say is there will be interdomain relationships. If you're familiar with the work that the Cloud Computing Standards Committee has put together, previously we released a standard for federation and interdomain relationships. And what we've done here is we've borrowed from that work and said, okay, look at when we establish a relationship with another domain through a cloud or whatever, we are establishing a one-to-one relationship between the two domains. That is, note, not we're offering out to everybody. It's managed as a individual relationship. In fact, it's managed as a individual one-way relationship. That is, we could be communicating one way out to a separate domain, or we could be communicating one way in, or we can be communicating both ways. In any case, the relationship models, that is, things like the vocabulary for the relationship, the operations, the business goals, and the governance rules, they are constrained by your local domain. If, for example, your local domain is not consistent and cannot communicate with the vocabulary or does not have consistent business goals, you really can't establish an interdomain relationship. Similarly, if you have an existing relationship with an external domain, and for some reason its vocabulary or its goals or governance rules or operations change and are no longer consistent with your local domain, you've got to either modify that relationship or in the worst case, you eliminate that relationship and so that you're not getting invalid or potentially bad requests that are occurring between the two domains. So in this way, what you can see is that there is, as the models get ever complex, as Bob illustrated in the use case, there's going to be a large amount of knowledge that is contained within the knowledge base. One of the questions that can obviously be asked, where is all this knowledge being kept? We've thought about that, and we're still thinking about that. We've got a couple of alternatives, but this is work that's in progress. I don't have a slide for that, but we're thinking that you actually can have at least two different alternatives. You can keep all of the external relationship knowledge from your side and the models in your local domain knowledge. We also have come up with a case where they can be kept in a third party and monitored by the third party, and then any changes to those would then be reflected back to local domain stimuli monitoring and adaptive analytic engines. So, summarizing, the goal of the effort is to provide a set of requirements, foundational requirements, I'll add that word in there, for a cloud computing ecosystem management environment that can provide rapid response to stimuli. It responds to both stimuli that have or are occurring into anticipated stimuli. So again, what we're saying here is the stimuli monitoring is sitting down there looking not just for things that have happened, but also monitoring the system and saying, hey, wait a minute, these are things that could happen in the future or that we know will be happening. It provides both a feedback and feed forward and feedback to the components of the management system so they can adapt to the environment being managed and to adapt to the goals, context, and things that are happening within the system itself, and adapts to, obviously, changes within the cloud computing ecosystem, both the local domain and federated domains being managed, and adapts to changes within the management system, and not only fixes things that are broken, but also encourages positive things to happen in the future. So, question, why are we here? Well, one of the reasons is, hey, listen, we'd love to have people join us. We have a very lively team. We meet roughly every other Wednesday at 12 Eastern time. You can give either Bob or I drop us an email, and we'd love to have participation, and we'd love to have your thoughts. And thank you very much for your attention.
Okay, it's great. Thank you so much for your great overview of the latest standard development in P2303, Joe and Bob. So now we have about 12 minutes. Let's just have a Q&A to answer a couple of questions before we can conclude this webinar. The first question I can receive from the audience, Bob and Joe, to see which of you would like to answer. The audience asks, can you describe how the AMCC would characterize the response to the recent CME event that had potential to disrupt the power grid? So who may want to answer this question?
Bob, you want to?
Sure. Thank you. And thank you for the question. So I see it. So we have an image of basically the power grid that we had on one of my architecture slides. So how would that prevent it? Well, there's a lot more to the power grid system than what's actually shown there, right?
Let me see if I can go back and find it for you, Bob.
Okay, great. Just go back to yeah, that's good enough.
Well,
yes, that's good enough right there. So we have the power provider and the power grid, but I'd like to mention, if you look inside the power provider image, there's several individual components there, and there's a lot of work done on the smart grid that has actually been able to analyze this, right? Or there's smart grid architectures, and each one of these components, like Joel mentioned, can have its own individual management system and then an overall management system to watch over it, right? So we would have to install that at each unit, and then how will that data affect it? Now, granted, some of them, I don't know about how the power provider. I would say the major power generator source, if you're using coal or nuclear or water power, you'd have to figure out if that really shut down. I think that would probably, you might not be able to manage it, but you would certainly be able to, hopefully be able to manage an orderly shutdown of it.
Okay, great. Thank you so much, Bob. So then there is another question from the audience. It said it is indicated that suggestions for adaptation will include metrics. So Joe and Bob, can you give us some examples of the type of metrics that your working group is considering?
Sure. And let me forward to that again, to that slide. as I mentioned mentioned that one of the things that we're looking at there is, for example, cost of implementing a suggestion, a revenue cost for implementing it, for example. That might be okay. Recommending a new equipment or a revised network. What's the cost of that? Financial cost. What's the cost of adding new equipment from the perspective of downtime, or updating a software of a system? Again, it might be a cost in downtime. That would be a metric that's associated with it. Or a metric also might be, if you're adding capabilities, there might be a metric associated there. Another metric might be anticipated revenue. So it's not just negative things, that is cost of penalties. It also could be a positive metric, that you're saying, hey, wait a minute, there's additional capabilities coming online, and that could be a positive source. So what we're looking at there is trying to make, I think the best way to put it is using the metrics to make a very informed decision based upon the goals and strategy of the local domain.
Okay, great. And Bob, do you want to provide any further insight, or at least sufficient from your point of view about the answer provided by Joe?
No, that's fine, Edward. Thank you.
Okay, so this question is a little bit more, quite big. Okay, the audience actually asked, because from his point of view, he understands that in the Cloud Computing Standard Committee, you actually have quite a number of working groups that not only focus on the P3303, which is the focus of the webinar today, that is the adaptive management of cloud computing environment, but you also have other job standard like intercloud, interprop, or the cloud computing share function. So at least a whole package that the cloud service provider need to use, or what are the dependency among these projects? So it may be a little bit big question, but we'd love to see how you think about these working groups and the related standards.
No, that's a very, very good question, Edward. Obviously, when I was talking about interdomain relationships and things like that, that drew very heavily on the work that was done in P2303 and the standard that was developed there. In addition, we have, both Bob and I and other have had very close relationships, and Bob still does. I have retired, no longer do, but we have had close relationships with the work that's going on in JTC1, SC38 on cloud computing standards. Also with Bob's certain employer, we obviously have close contacts with the NIST cloud computing work. And we have also a number of members of the very active members of the working group that are involved in cloud computing standards in other groups, for example, the OMG and things like that. So what we're trying very hard to do is not to develop something that would be, if you will, an isolated standard, but one that's complementary and draws very much on standards throughout the industry. And the anticipation is that we will indeed, this, like P2302 was submitted to JTC1 SC38, the anticipation is that this standard also will be submitted by the IEEE to SC38 for their approval. So it will be a joint standard. That's the anticipation, and that's our goal.
Okay, great. Thank you, Joe, for the answer. So, Bob, do you have any further elaboration?
No, I'd just like to mention that we also have the entire Cloud Computing Standards Committee, that manages all of our activity, and we had 2301 much earlier on cloud computing environments and definitions. So,
okay, great. So I don't see any further questions. So let me try to conclude the webinar. Okay, so let me go to the last slide. Okay, so once again, I would like to express my sincere thanks to Joe and Bob for joining us today and sharing what is going on in the world of cloud computing standards in our computer society. Actually, you as an audience of this webinar can be part of a standard board activities such as this one. Please stay tuned for our ongoing calls for participation and get involved today. Being a part of this community is an opportunity to share your insights with like-minded individuals from across the world. You can also visit our official website, computer.org, to find ongoing calls for participations for different standards. And lastly, quick programming notes. In the latest part of this month, we will also host 2 additional webinars. If you want to leverage artificial intelligence to drive greater project efficiency, reduce risks, and ultimately enhance project success in an increasingly complex and data-driven business landscape, you can consider joining us for a special webinar entitled The Interaction of AI and Project Management on May 16th. And as you may know, in April, our standard activity boards have a town hall meeting, and also our president of the Computer Society, Judica, also have her first town hall meeting in March. Actually, on May 29, you can also join us for our Society Quarterly Membership Roundtable with President Judica and our Executive Committee leadership. And through this quarterly membership roundtable, you will have the opportunity to learn more about what our member and geographic activities, professional and education activities, publications, standards, and technical and conference activities are doing to all of us here and you as the members of Computer Society. So once again, thank you so much for joining our call today and also for a lively Q&A discussion. And thanks not only our speakers, but also all the audience here and also our society staff for the support here. Thank you again and have a great rest of your day. Thank you, and the webinar is now concluded. Bye-bye.